section 3-4. We're doing example 2, and we're going to do another proof. Try to speed this up just a little bit. In your electronic notebook, if you will go ahead and write down these 3 theorems. If you want to shorthand, because this one doesn't have a title to it, this is a great way to shorthand it right here. This is what the theorem says. If 2 intersecting lines form a linear pair, we know what a linear pair is. If they form a linear pair of congruent angles, then the lines are perpendicular. The only way you can have a linear pair, that is 2 angles that add up to be 180 degrees that are congruent, is if both angles are 90 degrees. That is the only way. So that means that that line L has to be perpendicular to line M. That would be the conclusion you would draw, because the angles formed there that you see with the arcs have to be 90 degrees. Okay, and if you want to shorthand that, then this is how I would do that. 2 intersecting lines form lin pair of congruent angles, and then an arrow lines perpendicular. That would be a shorthand way of writing that. I think there's enough information there for that theorem for you to do that, and then I would try and get your conclusion down there, okay? Perpendicular transversal theorem, now that has a name, so you can call it that, or call it PTT, or whatever you want to call it. In a plane, if a transversal is perpendicular to one of the 2 parallel lines, then it is perpendicular to the other. So what they're saying is, if this angle right here is perpendicular to that line N, and N is parallel to P, then this is also perpendicular. That's what they're saying, is that Q is perpendicular to P, those two particular lines. And then the last one, I would focus here on these 2 parts right here for your shorthand. If 2 coplanar lines are perpendicular to the same line, then the 2 lines are parallel to each other. So you're actually proving lines that are parallel using perpendicular angles is basically what you're doing there. So, okay, so we've got 3 things to consider, and what we have to do is prove using, we're trying to prove that line AB, which is right here, we want to prove that it's parallel to DC. All right, so that's what we don't know. That's what we need to prove. That's going to be our very, very, very last step. And you know me, I like doing my first step is all my givens. I like doing all the givens, but you know, if you want to split them apart for your own reasons, that's fine. If it makes sense to you, it makes sense to me. I'll figure it out. All right, so we do know that line AD is parallel to line BC. Okay, they gave that to us. You see the little arrow marks here indicating that they are parallel. And we also know that BC is perpendicular to DC. Okay, that was given as well. So no, don't have to really stretch that out too much. We know that that's given. So we've used these 2. Now where we're going with it, let me do a little erasing here to clear up the figure just a little bit. Where we're going with that is we're trying to show that AD is also perpendicular to DC, is what we're trying to do, okay? So we already know that BC is perpendicular, B as in boy, BC is perpendicular to DC. Now we want to prove that line AD is also perpendicular to DC. Okay, that's not given. That's not given information. But do you remember what we just talked about with our theorems? You know, we have parallel lines. So if you have a transversal that is perpendicular to one of your parallel lines, then it should also be perpendicular to your other one, right? And so do you remember what that's called? And yeah, that's called the perpendicular transversal theorem. There's my shorthand for that. You can call it PTT. I don't know. Whatever works for you works for me. As long as you can remember the next day what you're talking about. Okay, so we proved that. And now let's go back and grab this AD. Line AD is perpendicular to line AB. Okay, that's given. Okay, so we've got all our givens are on the board now. Okay, so now our very last step, are we ready to say that line AB, are we ready to say that it's parallel to DC in just this fourth step? Are we ready? Do we have enough information here to prove that? And I think we do. So do you remember learning that if you have two lines perpendicular to the same line, that they have to be parallel? And that would be the very last one that we learned, theorem 3-4-3. And so I'm going to use the shorthand for that. Two lines perpendicular to same line. And then we're going to have parallel lines. Okay, so I know that was a little rough, and you know, we got to get used to doing these proofs and using our logic to figure this out. Let me see what's on the next page. Nope, I didn't leave you a bonus. We'll have to practice this one in class tomorrow. So if you need a little bit of extra help or you need some extra time on this, mark it so we can talk about it in class. Thanks for listening.